Hello everyone, respected sir and dear all friends. I am Ajay Kumar Chandrakant Patel. Today I am here in front of you all to present my video presentation. My topic of the video presentation is cluster sampling. So let's we start further in detail for the presentation. First of all, in the cluster sampling, we will see the definition of cluster sampling. The cluster sampling is basically defined as a sampling technique in which the population is divided into already existing clusters. So basically clusters, that means the groupings. And further, then a sample of the cluster is selected randomly from the population. So this is how the cluster sampling works. Second thing is what term that the cluster refers to. So the term cluster refers to a natural but heterogeneous intact grouping of the members of the population. And we will also see what is the most common variables in this particular sampling. So in the cluster sampling, the most common variables are geographical area, buildings, schools, etc., because in which the more and more sampling for the survey is needed, and it is one of the good sampling frame. So the next we will see which are the types of the cluster sampling, and this we will see this one by one chart. So you can see in the screen that the cluster sampling is basically divided into three parts. It's a one-stage sampling, two-stage sampling, and multi-stage sampling. And in the two-stage sampling, there are also the two parts: simple cluster sampling and the probability proportional to size sampling. So this is how all the cluster sampling and its division into the other sampling methods. Next, we will see how it is used in the practice. So we will see by example, step by step. So let's consider first example. Imagine someone want to evaluate the consumer spending on the different types of transportation in the London, one of the great city. So since London is a very large city, as well as the great and as well as the large as well, so we need to sample from only few of them districts or boroughs from all of the districts. So let's select only 8 boroughs from the 32, and there are the 3 stages for the application of the cluster sampling. First of all, we have to select a cluster grouping as a sampling frame. As in example above, 32 boroughs of the Greater London represent the sampling frame for the study. Second one, we have to mark each cluster with a unique number, so it will be easy for our process. So we can easily number each borough from 1 to 32 in our example. And the third step is we have to choose a sample of clusters applying probability sampling. So we can choose by systematic random sampling or any other probability sampling as well. So you can choose 8 boroughs from total out of 32 boroughs, and household residing in 8 boroughs will represent samples for the whole study. So this is how it is used in the practice. such instances. That is why I am saying it's more general for that. So effective sample size is equal to summation of I is equal to 1 to n wi the whole square upon summation of I is equal to 1 to n wi the square, where wi is the weight of the ith respondent. So these are the two formulas to calculate the effective sample size. Many researchers use sample size as a guide to understanding the likely sampling error in surveys, opinion polls, textbooks, and like the often present tables showing how standard errors, margins of errors, or confidence intervals vary by sample size. For example, with a sample size of 300 or 400, let me take particularly 300, an estimate of 50% will often be presented as having a margin of error of 5.7%, which is computed as like 1.96 as negative 1.96 into under root of s square into SRS, s square under root s square SRS into 100%, where the design effect is other than 1. Both the tables and the initiative understanding that most researchers have about the effect of sample size becomes incorrect. The effective sample size is an estimate of the sample size that a survey conducted using simple random sampling would have required to achieve the same sampling error as computed in the study that did not employ a simple random sampling. The effective sample size in this example is computed like using the formula. We are going to use the first formula. Effective sample size is equal to n upon DEFF. So it is equal to 300 upon 2.5. So it is equal to 120. So yeah, this is how the concept of effective sample size. Next, we will go further for the sample variance. So the variance of cluster Y bar. So variance of cluster Y bar can be derived on the same lines as deriving the variance of the sample mean in the SRSWR. The only difference in that in SRSWR the sampling units are Y1, Y2, Yn dash Yn, whereas in case of here in the cluster sampling, cluster of Y bar the sampling units are Y1 bar, Y2 bar, Y3 bar dash Yn bar, as I said in the last discussion as well. So here variance of cluster of Y bar is equal to E cluster of Y bar minus capital Y bar the whole square is equal to capital N minus N upon Nn into SB the square, where the SB the square is equal to 1 upon N minus 1 into summation of I is equal to 1 to N Y the bar minus capital Y bar the whole square. So here in the CS, no units from the non-selected clusters are included in the example. They are represented by those from selected clusters. While this differs from straight-to-bed sampling, where some units are selected from each group as well. So this is how the example as well. Thank you very much for listening me.